Hello friends, welcome to my channel Civil Smart. Today we are going to design a concrete load bearing wall, RC wall, a load coming from the slab. We are going to design the reinforced concrete wall. So we have a problem like it's a load bearing wall having a height 3 meter and length is given 4 meter. Carries a factored load. Factored load is coming on the wall from the slab, that is 400 kN per meter through the floor at the top, and assuming that there are no opening in the wall, use M20 and FE415. Right, we have to design the RC wall. So the thing is that this wall carries a vertical load only. The shear wall will be considered in the next video, in the next Excel sheet. So today we are going to design the RC wall. So we have the input data. You have to put your data in the pink cells only. These sheets are editable. All the sheets are editable. You have to put your data in pink cells. Then you will get the results by this sheet. We will design it by different steps. And the steps are determine the thickness of the wall. It will calculate the thickness of the wall as per the IS code. Then the second step is determine the effective height. Effective height as per the IS code. It will calculate the effective height. And it will check for the slenderness ratio, that is given that the effective height divided by the thickness should always be less than 30. Then only it will do the okay. Determine the design strength of the wall. The strength of the wall, we have to calculate how much the strength of the wall is there of the RC wall, and there is a check that the vertical load coming on the wall from the slab should always be less than the design strength of the wall. So the strength of the wall should always be greater, right? And finally, the last step is design of the reinforcement. So as per the IS code, we have to design the reinforcement and the spacing of the reinforcement and the die of the bar we are going to choose, right? So let's start. What we have given that the height of the wall is 3 meter. So we put this here, the 3 meter is the height of the wall, and length of the wall is the 4 meter. And factored load, we have given factor load of 400 kilonewton per meter from the slab, from the floor, right? FCK in our case is how much? 20 Newton per mm square, and tensile strength is FE415, right? So finally, as per the code, we have IS 456. As per the code, page number 61, the code says the minimum thickness of the RC wall shall be 100 mm, right? So here is the minimum thickness, and the second is lesser of the HW by 25 or LW by 25, right? What is HW? HW is 3 meter height of the wall and length of the wall. So take lesser of from the above, that is 120. It has been taken minimum of the above, and finally the final thickness to be provided is 120 mm. That is minimum thickness should be 100 mm and the lesser of these is 120 mm. From this, that take the higher one is 120 mm is the thickness of the wall coming, right? Next is it has been calculated. Determine the effective height. Effective height formula as per the IS code. This is the effective height. Effective height of the brace wall where the restraint against the rotation at both ends. It has been given by 0.75 HW or 0.75 L, whichever is less, right? So we have the restraint condition. The effective height is lesser of the following. So minimum of the above. It has been calculated 2.25, and we have to check for the slenderness ratio as per the IS code. IS code says the maximum effective height, which has been calculated, divided by the thickness, it has already been calculated, should not exceed 30 mm. In our case, it is coming as 18.75, hence it is okay. Otherwise, it will show the redesign. Go for the redesign, right? Next is determine the design strength. Design strength is given by of the wall is given by this formula. This is PW is 0.3 T. T is the thickness. 1.2 E. E is the eccentricity of the vertical load, and 2 EA. EA is the additional eccentricity due to slenderness effect. There is a slenderness effect, so additional eccentricity will come, right? So formula has already been given in the code for eccentricity. This is the formula for design strength of wall. That is the formula E is the eccentricity of the load at the right angle, and E is the additional eccentricity due to slenderness ratio. This is the formula HW by 200 500 into T, right? So there is the square in this formula. We have to take the square of effective height, right? So it has been calculated. E is calculated as 6 mm in our case, and EA is already calculated by this formula in 16.88. The design strength of the wall came, these two values put in this formula. The thickness has already been calculated, that or the design strength of the wall PUW came out 474, and the vertical load is 400 mm. Hence it has been written as, hence the wall can carry the applied load, right? If we change this load by 400 to 500 kilonewton per meter, then there is redesign, right? Because the design strength is 474, it will always be 474, but the vertical load is greater than this. So what we have to do, this is the formula, we can increase the FCK value, right? We can increase our design strength FCK. We can use, in this case we can use M25. FCK is 25, M25 grade, then there it will come, the wall can carry the load, applied load, because the load is 592 and we have vertical load is 500, so it is satisfied, right? So in our case load is 400, this is FCK is 20, right? So this is satisfied. Finally, the design of the reinforcement. IS 456 clause number this, page number 62. Vertical reinforcement shall be spaced not farther than 3T or 450 mm, whichever is less, right? So we have calculated 450 mm, 3 times of thickness is 360 mm. It has been calculated from the both, the spacing is minimum of above, and finally we have adopt 300 as a spacing, right? So width for which we are designing is 1000 mm. Always it will be 1 meter, that is 1000 mm. So as per the IS code, AST required for vertical reinforcement, these are the vertical reinforcement, right? So AST required, the formula is given 0.0012 times of B into T for up to 16 mm dia. So this has been calculated 144 mm square per meter, right? And for above 16 mm dia, this is the, for vertical reinforcement, for above 16 mm dia, this is 0.0012 for deformed bar not larger than 16 mm dia, for characteristic strength 415 Newton per mm square, right? And for greater than 16 mm dia, 0.0015 mm, right? So it has been calculated as vertical AST is 180 for this much of greater than 16 mm dia. So we are assuming 8 mm. If we are assuming 10 mm, then 300 is spacing will be coming from 300 mm and about 545, so then it will take automatically as 300 mm, whichever is less, right? So if we take 8 mm, then it will 8 mm vertical spacing, right? For horizontal reinforcement it is 0.0020 for deformed bars, and for up to 16 mm dia and above 16 mm dia it is 0.0025 of B times T. So the formula is written over here. So finally it has been calculated, horizontal reinforcement is 240 for 16 mm dia, and for above 16 mm dia it is 300. So if we take 8 mm, the spacing came is 209, round of figure is calculated as 200 mm. If we take 10 mm, the spacing is 300 mm. So for 8 mm, this has been calculated as 200 mm. So 200 mm or 300 mm, whichever is less, it will be taken as horizontal reinforcement. So it has been provided as 8 mm, 300 mm center to center vertically, and 8 mm, 200 mm horizontally on both faces. These are the two faces of the wall, outside face, inner face. So horizontal and vertical, this is the detailing of the reinforcement. This is the wall. So for vertical, if we are providing the 8 mm dia, for the vertical reinforcement 8 mm at the 300 mm center to center, right, on the both faces. This is the face 1, this is inner face, right? For horizontal reinforcement 8 mm, 200 mm center to center on the both the faces, right? So if we change our data, If we change our data to 5 meter height, 4 meter and 6 meter length, so the thickness has been changed as 200 mm. So this is okay. Effective height is calculated. PW is calculated. Design strength is 790. Vertical load is 400 mm. If we increase the load as 600, the load can carry by the wall. So design the reinforcement, it has been calculated. 8 mm 300 mm center to center and 8 mm 120 mm center to center horizontally on both the faces, right? So you can change your spacing, you can change your dia of the bar, so it will already calculated. So friends, if you like this video, subscribe this channel for more design videos, and if you want this video, the link is available. These are the paid courses. You can have these courses by paying some amount and you can get the access, and you can edit the sheets already available in my channel. Thanks for watching.